Alright, so the first objective we have to do of 3 is to graph functions expressed symbolically and show key features of the graph by hand in simple cases and using technology for more complicated cases. And the part E of that is graph exponential and logarithmic functions showing intercepts and end behavior, and trigonometric functions showing period, midline, and amplitude. This will come from the Ferris wheel, which will have X amount of cars on it. It will go around and round, and you have to calculate the height of each car stationary and then the height of a particular car after so many turns of the Ferris wheel. And you will graph those heights in relation to the number of turns. And then the second one, F-TF.A.1, understand radian measure of an angle as the length of the arc on the unit circle subtended by the angle. In other words, every degree measurement in a circle can be expressed as a radian measure. For example, 90 degrees is pi over 2. 180 degrees is pi. 270 degrees is 3 pi over 2. And if you go all the way around the circle, 360 degrees is 2 pi. And the third objective in this lesson is explain how the unit circle in the coordinate plane enables the extension of trigonometric functions to all real numbers, as interpreted as radian measures of angles traversed counterclockwise around the unit circle. Here's the first and maybe only example, the whole period. A Ferris wheel has 6 cars on it. The height of the Ferris wheel is 100 feet. Part A is to find the height of each car. Part B, find the height of car 3 after 1/3 of a rotation. And Part C, graph the height of a single car as it travels in a circular motion around the Ferris wheel. So this is a Ferris wheel, in case any of you don't know what a Ferris wheel is. This one has more cars on it than what we want to deal with right now. The one we have for this problem has 6 cars on it. So the first thing that you should do is to use this blank circle over here that's sectioned off into 4 quarters. In other words, 0, 90, 180, and 270 degrees. And we want to make 6 cars on that. Okay, so let's do a little bit of math on the side of this. A circle has how many degrees? 360 degrees. And we have how many cars on this Ferris wheel? We have 6. So we're going to have to divide this up into 6 pieces. If I divide 360 by 6, I have what type of angle that each or every 2 cars is creating at the center? 60 degrees. Okay, so the reason why these marks are on here like this is so that we can have something to go off of. There's 0, 90, 180, 270, so that we know what we're dealing with. Right about here would be a 45, approximately. So we need 60 degrees to start with. So 60 degrees would be approximately here. So if that is 60 degrees, we're going to mark that one off right now. Now if I go another 60 degrees, then what angle measurement would that put me at? 120. So here's 90 and 180. Halfway between those two would be 135. I just need 120. So approximately here, 120. And these are the cars. I'll circle the cars that we have. Of course, we have one right here at 0 degrees. And if I add another 60 to 120, where's that next car going to be at? 180, yeah, so there's another car. So I have 4 cars so far. All right, between 180 and 270, the halfway point is approximately here, and that's 225 degrees. If I add another 60 to 180, then how many degrees is that? 240. So 240 would be approximately here. Over here, halfway between 270 and this is also 360. That would be approximately there, and that is 315. If I add, and this was 240 here, if I add another 60 to 240, what does that put me at? 300. So 300 would be approximately here. There are the cars that we have marked off in terms of degree measurements. Now, we need car numbers. You can start the car numbers at the very bottom, because when you get on the Ferris wheel, you don't take a running leap and try to jump on it while it's like 50 feet in the air. You get on at the bottom. You could call that car 1. But how about we just call this car 1, car 2, car 3, car 4, car 5, and car 6. We want to put some spokes on this Ferris wheel, and I'll put those in red. This will not be the neatest thing you've seen today, but I'll start in the center and go up there. Of course, we have one that's right there at 0, and then here's a 120 down to the center, and we have one here, and then there, and we have one here. Alright, so 6 spokes on this Ferris wheel. Now back to the problem. It says, after it has 6 cars on it, the height of the Ferris wheel is 100 feet. Okay, so here's what we mean by 100 feet. From the bottom of the Ferris wheel, and there's all different kinds of ways that you could calculate in stuff on this. We could say from the bottom of the Ferris wheel is the bottom of a cart that's at the bottom. And then up to the top, to where the top of the cart would just be at the top of the Ferris wheel, is 100 feet. We could say 100 feet. Or we can just go from here to there. We'll just say from here to there, those 2 dots, 100 feet. Alright, so if it's 100 feet tall, I'll probably need a different marker. We'll use green. It is 100 feet tall. How tall is cart number 1? How high up is that cart if the Ferris wheel is 100 feet tall? It's 50 feet because the diameter of the Ferris wheel is 100. Therefore, the radius is 50. 50 feet. So that radius also pertains to this right here. So that cart is going to be 50 feet tall. That is really simple. Okay, but now we get to car number 2. Car number 2, we have to find its height. Here is how you do that. Alright, car number 2. We'll go to black. What have I done? I made a triangle, yes, and it is a right triangle. I made a right triangle that has a hypotenuse of what measurement? The hypotenuse is right here. It has a measurement of what? No, the length of the hypotenuse. It's 50, right? It's a radius. It goes from the center out to the circle. That comes back from geometry. 50. What side of this triangle would be most useful in finding the height of the car? Would it be this side or this side? This one? This one right here, yes. So we'll call that X. If we want to solve for X, we know that we need this degree measurement. What is that degree measurement that I have just marked off here that goes from 0 and then opens up to this point? What degree measurement is that? It is 60 degrees. Now look at what we have. We have a degree measurement, we have a missing side, and a hypotenuse. Hypotenuse, opposite, and adjacent. What is this side here from geometry? This side is what compared to this angle? It is opposite, yes. So if I have opposite and hypotenuse, what trigonometric function, sine, cosine, or tangent, is opposite over hypotenuse? It is sine, right. So we want to come down here and do this. Here's the triangle that we had. There's x, there's 60 degrees, and we know we have 50. This is opposite, and this is hypotenuse. Therefore, sine of 60 degrees equals opposite x over 50, which is the hypotenuse. You have to cross multiply to solve this proportion. X times 1 is x. And then sine of 60 degrees multiplied by 50. On your calculator, you would do this. Sine of 60 degrees and hit enter. You should come back with a value that we are going to round to 2 places every time. 43.30 feet. That's what we have so far. Is that the height of the car above the ground? No. What do we have to add to that? You have to add 50 feet, right. So for car 2, we came up with 43.3. So we have to do 43.30 plus 50 feet, which should give us 93.30 feet. So there's car 1, here is car 2. Next up is car 3. And car 3, we can draw a triangle like this, a right triangle, in which the hypotenuse has what side measurement? 50 feet. And then we need this angle measurement. What is that? It is 60. Don't make the mistake of using 120 just because it's written up there. Yes, that was my next point. My next question is, and he's already answered it, is that if your car is the same degrees from here to there as it is from here to there, is there any need to solve for the height of car 3? No, it's going to be the same thing. So keep that in mind. 93.3 feet. There's car 3. Car 4 is another easy one. It's just 50 feet. Because it goes up even with the center of the circle. If the radius is 50, that one has a height of 50. Do we have to solve for car 5? Yes, we do. Alright, so if we draw a right triangle here, what degree measurement is this degree going to be? It's going to be 60. Okay. So if it's 60 and this is 50, we will solve for the missing side x here, and will it be 43.30 feet?
Yeah.
Yes, it will. But is that the height of the car? Right. We will subtract it from 50. So 50 minus 43.3 feet 6.7 feet. All right. So this one has 6.7 feet. What is the height of car 6? 6.7 feet. Okay, so we have the heights of all of the cars. Find the height of each car. We did that. So part B, find the height of car 3 after 1/3 of a rotation. All right, car 3, we have to identify that. And I'm going to use purple and darken it up a little bit. Here is car 3. And car 3 is on this dot. We need 1/3 of a rotation. How many spokes are on this Ferris wheel? 6. 1/3 of 6 is how much? 2. All right, so we would start here, and if we went there and then there, that's 1/3 of a rotation. And then what is the height of that car? 6.7 feet, right. So we could fill that in over here. And then the last question is, graph the height of a single car as it travels in a circular motion. So here's the blank graph paper. And let's just use, I need my black marker again. There we go, and I need a line. Let's do this. Use that one, and I'm just going to draw this and then move it over. So there's one, there's my x-axis, and then here is my, oh no, that was my y-axis, and this is my x-axis. Okay, so we have x and we have y. The x-axis is going to be rotations. And then the y-axis is going to be the height. Now, how tall does this thing get? 100 feet. It's not going to go any higher than 100 feet. So we got to go from 0 to 100. We don't want to cram our graph into 2 blocks high. We have this whole page to work with. Ways that you can break up 100 are like 25, 50, 75, 100, or you could go by tens, 10, 20, 30, 40, 50. I don't know if we have enough to go by fives. We can check. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. What do you know? We do. So if we go in by fives, I could go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And then 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. So there's 100, 75, we'll make this 50, and then 25. Now the number of rotations, let's try to do this with at least 3 rotations. And make it easy on yourself. How many spokes were on the Ferris wheel? There were 6. So let's try to make it so that each block is 1/6 of a rotation. So I would have to go 1, 2, 3, 4, 5, 6. That would be 1 rotation. And then 1, 2, 3, 4, 5, 6. 2 rotations. And 1, 2, 3, 4, 5, 6. 3 rotations. At least try it like that. Car 1 was at 0 degrees. That's what we're letting car 1 be, and that's going to be our starting point. So the height of car 1 after no rotations is what? Is 50. So I'm going to come here and put a dot. What is the height of car 1 after 1 rotation? is how much? It was at 93.3. Okay, so on the next one over we'll go 93. Gosh, so now we have to count 95, 90, so it should be right about here, like that. And after another 1/6 of a rotation, what was the height? It was 1/6 of, it would be at the same thing. Okay, so it'll be, let's see, 1 over, and it'll go right there. And then what about another 1/6 of a rotation? 50 feet. So the next one over is going to go there. And another 1/6 of a rotation. 6.7, so that's approximately there. And another rotation, another 1/6 of a rotation. 6.7. Okay, so we go there. So that takes us around. Okay. Now if I go again, what's my next height? I have to go to 50. And then what's my next one? Alright, so it's going to follow the same pattern like this. And then I'd have to go down to here again. And then I would have to go down to here and here. And then back up to 50, and then back up here, and then back down to 50, and then down to here. Okay, now what does all this mean? Can you figure out, if you follow these in order, like a connect the dots thing, starting here, and I'll make my marker a little bit thicker. We'll do this. If I start here and go up, and then cut through that, and then back down, up through that, and then back down, and keep following the same pattern, there's my graph. 3 rotations.